Assalamu alaikum. So last time was discussing the transformation, and we did the transformation from the ABC reference frame, let's say, to the QD reference frame in the fourth stationary circuit. And we end up with a very simple representation. And if we recall, in the QD reference frame, the voltage equation, VQ of S was equal to what? It was R of S, IQS
d by dt
plus D by dt of lambda QS plus
omega lambda ds.
omega lambda ds plus omega lambda ds. What about VD of S? Rs IDS plus D by dt of lambda D of S minus omega lambda Q of S, and finally V0 of S will equal R of S I0 of S plus D by dt of lambda 0 of S. Correct? Yep. Good. And similarly, I think I recall that if I compare it with the separately excited DC machine, it was VA will equal to RA IA plus LA DIA by DT plus the certain K phi over. Right? Now, if I compare, we can see three terms. Yep. So the first one actually is what?
No.
Omni. This is, if I multiply by the current, it will be the losses. Huh? Until here, I did not multiply by anything. So this is a representation for what? Yeah, the voltage drop at a resistance, the state resistance. Yeah? So this is a voltage. A drop voltage across what? The resistance. And what about this one? This is induced voltage due to static coupling. Yeah? Like transformer. Yeah? There's a coupling between the windings, so I'm having what? Induced voltage due to what? To static coupling, let's say. So this one we can call it static induced voltage. Now the last term will be what? Now it's voltage. It's induced voltage. Due to what?
The rotation.
Due to rotation, correct? So the last one is induced voltage due to rotation. Now the same thing is applicable here, huh? And here, and here, correct? Yes? So the same thing, if I compare it with the DC machine, I have the same terms, correct? The first one is what? The drop voltage across the resistance. The second one is the static induced voltage, and the third term is what? Is the induced voltage due to rotation, huh? Good. Now the last equation here is described the zero sequence. I don't care with. If I'm discussing a balanced system, it will be zero. It will be zero. Consistent. It will be transient. But at the end of the day, I only need to carry those two equations. The main. Good. Okay. about if I need to refer a circuit on the rotor to the QD rotating frame, which means that, let's assume I need to do it for the rotor circuit. Now, if this is AS, and let's assume this is the BS, and let's assume that this is the CS. Here I'm having AR, and this axis is rotating by which speed? Omega. So simply from here to here I'm having a theta. Good? Now the same thing, I can have B here and CR. Now let's assume we have a reference frame. This is the Q and this is the B. Now this frame is rotating by which speed? Until here, omega. There's no specification for omega, so this is the arbitrary reference frame. Huh? The arbitrary reference frame. Later on, if I fix the speed that the reference frame is rotating, in this case I can say stationary reference frame, I can say synchronous rotating reference frame, I can say rotor rotating reference frame, for example. So let's assume now that our frame is rotating by omega. So simply now, if I need to do the transformation, this means that given FABCR dash, I need to calculate the FQD0R dash, correct?
Yeah.
So here what I will do, I will put what? KR, correct? And if I need to calculate the opposite, given the D, the Q and the D, I need to find the ABC, I need to find what? The inverse. So simply I will say that the FABCR dash will equal KR inverse the FQD0R dash, correct? And simply here, I need to find KR. So who can give me KR?
Sine theta.
Lambda.
KR equal to what? Now, if I think about it as, if I recall the stator, the stationary circuit, when we were referring, we use KS, correct? So, the simplest way to say that, I need to change the suffix from S to R, but also I need what? I need to change the angle. There, the angle between the X was what? Theta. Theta. Now, the X in between here, between AR and Q is what? So this is beta, let's say, yeah? Beta. And this angle beta is equal to what? Theta minus theta R. So this is the theta, correct? So simply I can say KR will equal to KS such that S go to R and theta go to beta, correct? So simply this means that KS will equal to, the factor is 2 over 3, and simply I will have cosine beta, then cosine beta 1, then cosine beta 2, and I think we specify beta 1 to be what?
Minus theta. Beta
Yeah, beta minus 2 pi over 3, and beta 2 to be beta plus 2 pi over 3. Otherwise you can write it. Huh? But simply this is to save some ink. Supposed to be. So sine beta, sine beta 1, sine beta 2, and in the end of the day here I'm having 1 over 2, 1 over 2, and 1 over 2. Yep. So what about the inverse? KR inverse will equal to, it's almost like the transpose, right? So it will be cosine So let's say C beta 1, C beta 2, S beta 1, S beta 2, 1 and 1 and 1. Huh? And simply I think we say that C sometime I will use it for the cosine and S I will use it for the sine. Huh? Good. So now if I need to do the same, I need to find the voltage equation in the QDR reference frame. So I need to write almost the same equation. Huh? So if we recall this one, if I write it in matrix form, this one in matrix form, VQ D0S will equal RS IQ D0S plus d by dt of lambda Q D0S, then plus omega. Here I will reverse the notation. I will say lambda dqs. Why? You see it, huh? So simply I need to define this term. Huh? This term now is new for us. So I need to define this one. So lambda dq of s will equal to what? Lambda d of s minus lambda q of s 0. And you know that if we define a term, it will solve everything. Yes? Yeah. So now I can what? I can write the equation in matrix format. Yeah? And instead of writing three equations, I will write single equation in matrix form. So I need to respect what? The notation. This is the QD. Here I say DQ and I define. Good? Good. So now let's try to write the voltage equation for the induction machine in the arbitrary reference frame. Now, the first one we already found, correct? Which was VQ D0S is equal to RS, this is a matrix, diagonal matrix. I Q D0S plus d by dt of lambda Q D0S plus omega, and here remember to switch. So this will be the dqs, correct? Now I need what? This for the stator, huh? This for the stator. So this is the stator voltage equation. Now what about the rotor? So here I will write what? V Q D0R dash equal to RR dash IQ D0R dash plus d by dt of lambda Q D0R dash, then
NS over
then
NS over
then
lambda of on lambda.
Then
I is constant.
I is constant when I need the last term. See, so I need to write a term similar to this one, huh? Now remember, this was due to what?
The derivation.
Derivation of what? Theta. Now I don't have theta, I'm having what? Beta. So I need to differentiate beta. So this term will be what? Omega minus omega r.
Oh, okay.
Yeah? So here I will have what? Plus omega minus omega r, and here I will have the same lambda dq r dash. The same thing, it will be the same, except that the angle between the axes are not the same. In the first one, it was what? Theta. Here, it's what? It's beta. Yeah? And remember, the term omega was due to what? Differentiation of what? Of theta. The differentiation of ks inverse, actually. Correct? The augmented function inside the matrix, the theta. Yes? Yeah, by chain rule. By the way, there is the chain battery. The famous one. معركة ذات السلاسل. It's very famous. The second famous after the Qadisiyya actually. Now wait. Good. Good. Okay. Now let's see. So simply this is the voltage equation for the induction machine in arbitrary reference frame. Why we call it arbitrary reference frame? Because omega here is undefined, correct? Now if omega equal to omega 0, so this is the arbitrary reference frame. Huh? So if omega equal to 0, in this case the frame is called what? Stationary. So simply this will call stationary reference frame. Now what about if omega is equal to omega e? The synchronous speed.
Synchronous.
Yeah, synchronous rotating reference frame. Which means that now the frame is rotating by what? By the synchronous speed. Now if the frame is rotating by synchronous speed, any alternating signal in the balanced system is seen as constant.
Yes.
Yes. Similar to the concept of the phasor. Yeah? So this is what the synchronous
Speed.
rotating reference frame. And if omega is equal to omega r, rotor rotating reference frame. So simply this means that the frame is attached to what? To the rotor, and it's rotated by what? By the rotor speed. So this is rotor rotating reference frame. And if omega is unspecified, it's called what? The arbitrary reference frame. Huh? The arbitrary reference frame. Good. Yeah.
Yeah.
Good. Now, let's discuss the advantage of the reference frame. The first advantage we notice that is the expression for the voltage equation is very straightforward. Yes? I can understand each term in the voltage equation. Yes? This is the first one. Now let's examine lambda QD of S, the inductance matrix. Let's see the inductance matrix. So, if we write the flux linkage, which is the lambda QD0S and lambda QD0R dash, we know that this is equal to what? It was the LS, KS, LS, KS inverse, correct? And this would be the KS LSR dash, KR inverse. Now here I'm having the current, the first current is IQD0S, the second current is the IQD0R dash. Now here I'm having the KR LSR dash transpose multiplied by KS inverse, and finally here I'm having KR LR dash KR inverse. Now you know why here I'm using KS and here I'm using KS inverse, and here why I switched the matrices. Simply the first one, this one due to the KS, I need to transform KS, and this one I need to transform what? The ABC up. Yeah? Now let's see. This is the flux linkage in terms of what? In terms of the arbitrary reference frame. So if I solve the first one, which is the KS, LS, KS inverse, if I do the math, this will equal LLS plus the mutual M or LM, 0 and the 0, 0, L, LS plus M, 0, 0, 0, and here I'm having what? LS without M, because that one, the last one is for what? For the zeros. And M here actually is 3/2 LMS. Now the first one, if I compare LS with this one is very straightforward, diagonal. But this will add nothing because LS was constant. Yeah, I'm simplifying the shape only. Now, what about if I need to find the KR, LR dash, KR inverse? This will equal to what?
نفسها
Except S go to where? To R. And dash. Don't forget what?
dash.
The dash. Yeah. So this will be the L, LR dash plus M, 0 and the 0, 0, L, LR dash plus M, 0, 0 and the 0, and here L, LR dash. The same thing. M is what? 3/2 LMS. Now, the problem was in where? In this term, correct? Do you remember? LSR was a function of theta r, which means that it's time varying. Now let's see what will happen when we do the transformation. So if we do the transformation, let's assume that I will calculate Ks, LSR dash, multiplied by KR inverse. If we do the math, this will equal to M 0, 0, 0, M 0, 0, and 0, and 0. Now this is very fruitful, by the way. Why? Because although LSR was a function of theta r, now the transformation of the Ks, LSR, Ks, KR inverse is constant. It's constant. And this is very fruitful. Now the system can be described in ordinary differential equation. Yes?
دكتور كم قيمة الام
3/2 LMS.
الMS ولا LMR ولا
No, LMS.
دايما
I think when we refer, we convert all the magnetizing inductance in terms of what? LMS.
يعني دايما كلهم LMS.
Yeah. When we refer. After referring the rotor circuit to the stator circuit, we exchange LMR with LMS, the equivalent LMS according to the theory. Good. So now we can write the flux linkage. And let's start with lambda QS. This is equal to what? Now simply, if I go here, I will say that lambda QS will equal the first line of this matrix is what? LLS plus M multiplied by what? IQS, correct? So this will be the LLS plus M multiplied by what? IQS. Plus the second term from here. From here I'm having only the mutual. Yeah? Yes? And this mutual multiplied by what? IQR. So plus M IQR dash, correct? Yeah? So simply this is seen as what? Self-inductance plus mutual inductance. Yeah, very simple. Even the flux linkage has a meaning. Yeah? It's very straightforward to write it. In terms of the machine variable, the ABC, it was very difficult. Why? I'm having cosine, I'm having a matrix which depends on what? On theta. Good. The same thing if I need to write the lambda ds equal to what? LLS plus M IDS plus IDR dash, correct? Yeah. Now someone will say that this one I can write it as LLS IQS plus M and add the current together. IQS plus IQR dash, correct? This will be more, let's say, easy later on to plot the equivalent circuit. This will be the LLS IDS plus M IDS plus IDR dash. Now for the zero, lambda 0s is equal LLS I0s, correct? There's no mutual there. Now what about the flux linkage for the road?
بدل محل اس.
Let's write this one. Lambda QR dash equal to what?
بدل اس صار
Yeah, so it will be LR dash IQR dash plus M IQS plus IQR dash. So this term is shared in between. This is the mutual between the rotor circuit and what? And the stator circuit, correct? So lambda dr dash will equal to what? LR dash IDR dash plus M IDS plus IDR dash, and in the end of the day, if I need to write lambda 0R dash, it will be the LR dash I0R dash. Good? Yes. So now I can write, let's say, the arbitrary reference frame equivalency. And let's do it here. So let's write the arbitrary reference frame. Equivalent circuit. And let's start with the Q axis. So here I will write VQS. So simply the meaning of what of the equivalent circuit? I'm trying to represent the equation in terms of what? Q. In terms of what? In terms of circuit elements. Resistance, inductance, current source, voltage source. So now what I'm trying to represent the abstract math with a physical system, the meaning, circuit component, the meaning. So if we recall here, let's recall here. If we recall here, VQS will equal RS IQS plus D by D of T lambda QS plus, here it was omega lambda ds, correct? Yeah? And if I recall the VQR dash, it will equal to RS IQ RR. It will equal RR dash IQR dash plus D by dt of lambda QR dash. And here what I will put? Omega minus omega R lambda dr dash. Yeah? And if we recall, lambda QS was equal to LS IQS plus M IQS plus IQR dash. So simply I'm having a coupling, yeah, between what? The Q of the S and QR. Yes? So I will try to represent this one. I will try to represent the first one. The voltage equation, BQ of S, so this is BQ of S, plus, minus. Now the first thing I will face here is a drop voltage across what? A resistor. So this will be RS. Small, huh? We write this small. RS. Then I need to represent what? D by dt. So this is what? Inductor. This was inductor. But simply this one contain what? Contain self and mutual. So simply this means that I'm having, I need to have a self-inductance, LLS, and mutual. But also here what I'm having, it's like voltage source. Yeah? So this voltage source has a value which is omega multiplied by lambda. So simply here I will add a source plus minus omega lambda dr. Now I will put the inductance. So this will be the L, S, and this will be what? That. Now the current flowing here is what? IQS. The current will flow here as well.
IQS plus IQ.
So I need now to connect what? The VQR dash. Yeah? So now I will try to do this one. Huh? The first thing I will face is what? The drop voltage. Correct? Which is RR dash. Then I'm having what? A voltage. Yeah? So the voltage source will be the plus and the minus. This is the plus. And the value is what? Omega minus omega R lambda dr dash. After that, I will put the self-inductance and I'm having the mutual, which is the LR dash. Now the current here is what? IQR dash. Good? Yes.
دكتور اخر شيء على الشمال الفولت سورس اوميجا لامدا دي ار ولا دي اس؟
دي ار اللي فوق.
Yes. Where?
على الشمال.
This one? Yes, this one.
دي اس.
I'm sorry. Okay. Okay. Now, simply, this value from here to here represents actually lambda QR dash, correct? And this from here to here will represent what? Lambda Q. Now, who can help me with, so this is the QX. Who can help me with the DX? So the first thing here I will do what?
PDS.
VDS plus and the minus. The first thing I will face is what? RS. Then, and this voltage source will be minus plus. Minus. The plus, the value is omega. Lambda.
And the QS.
QS. Then I'm having the self and the mutual. L, S, and M. Then VDR dash. First thing here I will face is RR dash. Then a supply where this is the minus and the plus, and should be omega minus omega R lambda QR dash. Then I'm having the self-inductance, which is LR dash. So now this will be the IDS and this will be the IQ. Yeah? Now, question, 1 point. Question. This supply is supporting VQS or resisting VQS? Resisting VQS, ها؟ مين قال resisting؟ بس ليك عامل. شو معنى؟ ليش؟
دكتور عكس بعض انه لما تيجي تاخذ كي في ال بتطلع دكتور الكرم الثاني اي دي ار بالسيركت الثاني
IDR dash. Yes. IDR. IDR. شايفوا
شايف
يعني قصدي مكتوب صح؟
بس لازم يكون في داش صح؟
From now on, I will not write dash to save ink. So from now on, yeah, any rotor, let's say quantity, is assumed to be referred to the stator. So I will drop the dash. But for you, I will add. But the last thing, who can give me the zero? The zero x.
بس الماتش هو
Yeah, so simply it will be what? RS. مين حكى؟
هلا بي 0 اس بتكون ار اس تمام والاندكتنس بتكون ال
لا مش الاندكتنس دكتور عادي
That's the mutual. It will be the LS. LR dash. RR dash for you. And V0 R dash. Good. So this is the 0x. So this is the equivalent circuit. Huh? By the way, from here we can drive the bare phase equivalent circuit, the steady state, the famous one. From here. Actually. Good. Now, until here also we have what? Let's say state some advantages for the reference frame. The first one, we simplify the Botry equation. The second one, the inductance now become constant. The third one will be what? Yeah, we have. If the voltage equation is very simple, simply I can get equivalent circuit. Now, in the end of the day, I need to find a torque expression. Yes?
Yes.
Do you remember? In the ABC reference frame, it was tough actually. Although it's very simple, it was partial omega C by partial theta Rm, and omega, the field energy and the co-energy are the same because we are assuming a linear magnet circuit. But simply, let's say, the resultant formula is very complex. Yeah? I cannot understand which term I need to manipulate, which term I need to control in order to control the torque, correct? Now here, let's try to find an expression for what? For the torque. For the torque. Or we can say out power. It will be the same. If we have out power or developed power, I will divide by omega Rm, and I will get what? The developed torque. Good. Yes? Now, someone will say, I can do the same, which means that I can go to the ABC reference frame, and if I still remember, the torque was equal to what? TE was equal to what?
partial
It was partial omega C by partial theta Rm, correct? Yes? And if I do this will equal to what? It was IABC transpose partial LSR by partial theta, and if I do so, I need to multiply here by P over 2. Then here will be what? IABCR dash. Yeah? Good? Good? And simply what I will do? I will do the transformation, which means what? Remember, if I'm having ABC, FABC, and I need to get, let's say, the FQD. In this case, what I will do? KS inverse. I need here to multiply by what? K inverse, let's say, because here I'm not putting anything. So if this S, this will be S, this will be S. If this R, this will be R, this will be R. Yes? Yep. So someone will say it's very straightforward. So, yeah, no one. One. Can you give it to me? And I will give you 1 point. Yeah. P over 2.
okay. P over 2 on ABC.
دكتور مش لازم
مش بالعكس
كي اس
احنا بدنا كيف احنا بدنا كي دي
صح
The meaning that this one will equal this one multiplied by this one.
ايوه
هيك meaning. هيك. This is what I meant.
انت مش عم قصدي الانفرس
لا
المفروض اف كيو دي يساوي كي اس
كيف ايوه
So simply I told you that if I'm having this one, I need this one, so I will put one. Yes, in there.
اوكي
شوف ايش
if q d equal k
KS
بدون انفرس without inverse
كانت الأولى صح؟
Now simply if I'm having F, A, B, C, I need to put K. S, okay, this is the S, and this would be the F, Q, D.
هسه بدي
Just
هيك
yeah, this is it.
آه.
So this is what I meant. If I need this one, I will put this one by this one. So, no what?
دي اوفر 2 هلا كي اس انفرس باف كيو دي 0 دي 0 اس اي
Ah.
بي
اي كيو
هلا دي سي ترانسبوز اللي هي اف
اي
اي
كيو
كيو
اي كي
ترانسبوز
There's no point for me. Then,
كي اس
كي ار
بدون انفرس اي كيو دي 0
so I will take the point. Ah. Yes? So someone will say it's useless. Why I'm doing so? Can we calculate it from the voltage equation? Yes or no? And to be, let's say, okay, to make it very simple, let's assume that I will choose either the stationary reference frame or the rotor rotating reference frame. So if I have a choice, I will say that I will use omega equal to omega 0. So let's assume that I will discuss the torque expression when omega equal to what?
Zero.
Omega. Yes? Omega, let omega equal to 0. Good? Which means that the frame is what now?
stationary.
Someone said, if I change the frame, this will change the torque? No. Because if the torque is changing, the speed are the same. The rotor speed is not changing, correct? The rotor speed is physical rotor speed. So if the torque is changing, this means that the power will change. And it's impossible. If the power is changing, if you are doing the transformation, then you are changing the system. You are changing the system. You are modifying the system. Yes? So this means that whatever I'm using to discuss the torque, it will be the same. Yeah? It will be the same. Okay. So if omega equal to 0, what I will have? In the stator circuit, do I have omega? مستعجل. لا لا. مش مستعجل. عشانك مستعجل خلينا نرجع. This is what? The stator equation. If omega equal to 0, this term will equal to what? 0. Yeah?
Yeah.
So I will not carry anything with me. Because in the end of the day, if I need to calculate the input power, it will equal to what?
VQID.
The input power. P N equal to what?
I
It was 3/2, I think, due to the transformation, correct? then it will equal to what?
VQ
IQ plus
plus VD
VD
ID
ID
plus
plus
2
2 V0 is 2, huh?
yes
Is 2 plus
2v0.
2
V0 ID
V0 ID. So of course here I need to add, this is the S, the S, the S, the S, the S, the S, because I'm having stator cells and rotor cells. So here I will have a VQ R, IQ R, and I will drop the dash. Plus VD R, ID R, plus 2 V0 R, I0 R, and or R is referred to what? Good. Now, if omega equal to omega 0, let's do that, let's do that, let's do that. Oh, let's stop here to give you the question.